I've been writing software for a long time, and it seems the simplest and most important lessons take the longest time to truly learn. The lesson that took me a long time to learn and embrace as absolutely necessary, and the lesson that I would like to share with you today, is that almost every software application should start with and revolve around an API. I would like to go further and say an API isn't an API at all until it has been productized. Well, what do I mean by that? It can't just be your ad hoc RESTful endpoints running on your backend. You need live documentation based on a specification where developers can try out your endpoints with almost zero effort. You also need to meter and monitor usage, as well as provide uniform security, no matter how many microservices, frameworks, or programming languages make up your API. And you also need a developer portal that is dedicated to making your API easy to use. In short, you need API management. Let's make something interesting. I happen to be very interested in cryptocurrency, and I want to make the world's most powerful Solana blockchain development suite. So where do we start? You guessed it, we start with the world's most powerful Solana API. In this tutorial, we are going to create a swap function. To make this more interesting and personal, I actually created my own token based on the Solana blockchain. And if you're interested, you can go to solscan.io and see that there is, in fact, a token called Enterprise Web Service. It has a max total supply of 100 million tokens. There's actually 36 holders. And I created a liquidity pool that consists of, two sides of the pool, which is USDC and then EWS. And that just simply allows swaps between those two tokens to occur. So if somebody purchases USDC, they can trade it for EWS. And you can do that on Radium. So we're going to create an endpoint that allows us, just like we can swap here, if you go to Radium, you can put in USDC, EWS on the swap tab and say how much USDC you want to swap for EWS. All right. I'm going to go ahead and do a swap in this official application. And just to give you an idea of how it works. So I have the USDC stablecoin, and I'm going to purchase more of my own token, Enterprise Web Service, from the Radium liquidity pool. So we have currently 341 Enterprise Web Service tokens in my Phantom wallet. And when I come in and say, I want 0.01 cents worth. So once this refreshes its pricing information, it calculates that for 1 cent, I can purchase 40 of my EWS token. All right, I'm going to hit swap. It asks me to approve. And we can come in here and see that the amount has gone up to 382 Enterprise Web Service tokens. We're going to do the same thing, give us that same ability, but we're going to write the code and put that in an API and do it ourselves. Now, if you've been in this crypto ecosystem for a while, you'll see that a lot of the examples are written in Node.js, TypeScript, so a lot of JavaScript, and there's a lot of people writing applications that mix a bunch of user interface code that do connections to the Solana blockchain and a whole bunch of work and logic inside user interface code where it shouldn't be. So I'm extracting all of that and I'm putting it where it belongs in an API so that the user interface code can focus on what it should do. rather than focusing on the business logic of performing swaps or other types of crypto-related logic that doesn't belong in the user interface. Okay, so I have some code here, and it's surprising how much it actually takes to do a swap. Now, this swap is specific to the Radium liquidity pool that I've created, but we can do it outside of the Radium application. All right, so let's say we've got this TypeScript Node.js application. What's nice about our API is, so we have our post for swap. There is a lot of work that gets done here. So get swap amount. When we put in that 0.01 and we get back dynamically what the value in return should be in EWS, we have to get information about the LP token address, and there's a bunch of pool information and values that need to be dynamically extracted and created. For example, all of these files are involved. Getting information about liquidity pools, and doing the swap itself takes a lot of potential. There's a lot of potential work that could have to be done, and now we have all of that encapsulated in a nice API endpoint. All right, let's run this locally and show what we can do. Okay, I'm going to compile the TypeScript down to JavaScript, and then I'll do an npm start, and then we can bring up the application. Okay, and one of the things you'll notice, now this isn't the documentation that we'll be putting in our development portal for the API, but it is something that's useful during development to try things out. So I've put in a library called JSDoc that allows me to put in my bits of open API specification above the particular method, particular endpoint that I'm creating. And that will get generated and displayed in my API docs endpoint. So I've got a swap here, and our final documentation will look something similar like this. This gives us a nice start to the documentation and the open API specification that we'll be putting into our final managed API endpoint. But for now, let's try this out. So I have a from token. And this is a lot easier than what you would have to do in code. So an API developer now, or a DeFi application developer, could easily come into this and see what they had to do to use the endpoint. We're going to go to EWS, and every token has a public address. And that's the public address of that token. We're going to provide a liquidity pair token address. That is the address of the tokens that have what's called liquidity that allows permissionless swaps of these two types of tokens. So that's basically a liquidity pool that has a certain amount of money that allows the transaction to happen in a trustless way. And we're going to say, what amount do I want? Let's do the same, 0.01, so 1 cent. We're going to allow slippage. So in case during our transaction if we were to buy a lot, and the price would be changing while the transaction occurs. This is the amount of slippage that we would allow. We don't need an API key. I'm just being proactive and putting in this parameter for when it goes into the 3Scale API management application. All right, and here's where we have some extra information. So I'm not going to be sharing this. I'm going to bring this off screen, putting things like my private key, the wallet public key, the address, that's fine. That's public, but I definitely do not want to share my private key. But what I'm doing is I'm putting that, it's going to be in an SSL encrypted request. It's in the request body rather than as a parameter in the URL. And for some extra precaution. So I'm going to take this off screen and I will populate that information that's required to complete the values needed for the request. Okay, I have populated the body of the request. I'm ready to execute. Before I do that, let's take a look at the value of EWS in our wallet. We have 382. And once we do the transaction using our code, we should have an extra 40. All right, let's go ahead and hit execute. And let's watch our Phantom wallet. All right, now we have 422 Enterprise Web Service tokens. And a little bit of Solana was subtracted and our USD coin. And our response body is a transaction ID for a successful swap. Now we need to get this in the hands of developers that don't want to spend their time dealing with these low-level requirements and this low-level amount of coding just to make a swap between two tokens happen. All they really want to do is know the input parameters for this endpoint and get on with the rest of their core business. This is where Openshift and 3Scale come into play. For the purpose of this video, you can think of Openshift as a near limitless development platform. We're going to use it much like we could potentially use Amazon's app runner, where as a developer, I want to run some code very much like how my code would run in production, deploy it like it would be deployed in production in an environment that I have access to other middleware that's also running like it would run in production, and not have to know very much about CI/CD pipelines, the deployment process, the native underlying aspects of containers, as OpenShift is a Kubernetes platform under the covers. So it will be running your applications as containers, but without having to deal with the underlying intricacies of everything that I just described about running applications inside containers. Let's take a look right now at how we can get our code up and running in the simplest way possible. All right, let's go into the actual developer view. And let's go ahead and add a new component. You'll see there, rather than use, a CI/CD pipeline of some kind, there are a lot of options here that you can, as a developer, just get up and running very quickly. One of the most likely ways that you're going to want to do that is via pulling your source directly from a Git repository. So let's go ahead and click this. And I have checked this code into GitHub. It's in a private repository, so you can select from your GitHub secrets that you've stored in the namespace. So I've stored that as an encrypted secret that this platform has access to. That then when I come in here, I can pull this. So my GitHub Solana swap. I will leave the default branch and the base context dir. And you can choose between these different types of builder images. Often when you put in your URL, it will go and take a look at the code that's at that repository and automatically select the type. If it doesn't, you can come down here and select it. So we're deploying a Node.js application. And so if you are familiar with creating containers, this takes a lot of the work out of that, right? You have a builder image already inside Openshift that pretty much knows how to run a lot of the, the popular languages and frameworks already that you're writing your code in. So by selecting Node.js, all it needs is your source control or your source code, and it will combine it with everything that it needs to run. All right, you can change the version to be the latest or any particular version that's available in the list. And I'm not necessarily going to make it part of an application group. So no application group. And I'm going to change the name to Solana Swap Demo. And here I'm selecting the type of resource that I want to generate. These are native Kubernetes types that you as a developer then don't have to create yourself. You're letting the platform create the deployment objects for you. But, right, it's still creating those things that you can ultimately hand to the CI/CD pipeline team, a DevOps team or the deployment team. And, they'll have a lot less work to do when it comes to moving this into the production CI/CD pipeline. Okay, do we want to create a route to the application? We can, or I'm not going to do that at this point because the route that we're going to use to get to this application is going to be via 3Scale. All right, I think we're good now, and we can go ahead and hit create. And we can take a look at what's being created here. And I do know that what we're going to want to do is come into this deployment and change a few things. So let's take a look at what it's actually done. One of the things that it has created is a build config. In the background, now we have all of these objects that normally would have had to been manually created. They're created for you. So the image has to be, the container image has to be built. And that's what this build config is defining. And we can take a look at our builds that are currently running. And we have logs that are telling us everything that's going on in the background. If you've built images before, you'll see something similar to instructions from a Docker file being executed. So step 1, step 2, but we didn't have to write any of that. We didn't write a Docker file. We didn't write a build config. We didn't trigger the build. The only thing that we did was pull some source code, and the platform knows how to get it up and running in a production level way. It's created the image stream. And once that is finished, it will push it to a registry that's internal to Openshift, a container image registry. And then that image will be pulled and then deployed. Our build is now complete. The image has been pushed, and our deployment should be pretty quick and have the container up and running. All right, let's take a look at our pod. Click on log, and our application is up and running and listening on port 3000 in this container. The next thing that we need to take a look at, so I've switched back to the administrator view because I wanted to show the builds and the build configs and the deployment objects. Let's take a look at a different project that I have running in this platform that is taking care of our 3Scale environment. So I've got the Solana API namespace. And if we go to the installed operators, I have the Red Hat integration 3Scale operator. Now, again, I won't go into great detail what operators are in case you're already familiar. You can look at some of my other videos that go into more depth of that type of information. But suffice it to say, the operator makes it very easy, much like installing like a mobile application, very powerful middleware software or complex software that is made up of a lot of different, potentially many different things, many different containers all running together. And it also, so this operator, once it's installed, lets you install and get running an instance of 3Scale and all of its components and manages that 3Scale as though you had an operator on standby that was keeping track of everything and what state the environment should be in. It also introduces these now new Kubernetes native custom resource definitions. And I'll go into a little bit about what some of these are. They're important for what we're trying to accomplish. The two main ones are 3Scale product and 3Scale backend. So in this API management tool, 3Scale, you can create a product, something that the end user or the end developer, right? The developer that is going to be taking advantage of your API, your product may consist of many different API endpoints and microservices, not necessarily all of the same domain name, same service name. They may be, you may have a product that's made up of, many different things that come together in a unique way. And that's where you can define your backend, multiple backends, and then combine them into a 3Scale product to create your final API product. So I'm going to be going into a little bit more detail of what all this means. Now, in the past, when you wanted to use 3Scale and you didn't have this operator that introduced these custom resource definitions, you could use the 3Scale toolbox and automate much of the creation of your API, or you could come in to the user interface through the dashboard and navigate to the various places that you needed to in order to create everything that you need. So that's clunky and cumbersome. We don't want to do that. One of the most powerful things that we have access to now with this operator is being able to define our objects, check them in to a Git repository, and have all of that work done for us in a declarative way. So I'm going to go back to my IDE, and I want to switch now to a different code base. So this is a code base that really is our configuration of the API. I currently have some backends and product definitions in place. So if we go back and take a look at our 3Scale environment, so we've got products. The product that we have is our Solana API. But I did that by checking this into a Git repository and then having that pulled into the Openshift system. And all of the work to automate and create these objects in 3Scale the way that I want them is done for me. So I define what I want. It creates the environment that we need. Since we created an entirely new application, or backend, if you will, we have to create another backend. So let's copy this. Let's add a new file and call it swap demo backend.yaml. We'll go ahead and change this to be Solana swap demo. Give it a name. Swap demo. And we did the same. So how this private base URL needs to be formed. We aren't going to be using an external route. OpenShift comes with internal load balancing and routing so that you can keep all of the traffic on the inside network, the network overlay. And what you need here in the private base URL is a combination of the project name with the application name, so the service name, project name, service, that cluster, local, since it's going to be running, right? It's in the network. So all the traffic that, since 3Scale is running in the same cluster as this service, then it can use internal routing using the overlay network in Kubernetes. All right, to show what I'm talking about, I'm back in the Solana backend project. And here's our service. It acts as a load balancer internally to the containers that are running our swap demo. And what that gives you is the ability to, one of the abilities, right, of many, is you could scale up the number of containers that is running our backend to as many as you wanted. And as long as you've used the service name, then the network will know how to route that traffic to the appropriate container. All right. So let's give it the Solana swap demo service name. And that should be good. So microservice for swapping Radium liquidity pool tokens. Liquidity tokens. Okay. Now you could check this in, or you could, right? What we're going to do, what you would want to do most likely for production is, right, check this into a Git repository and have that be part of a pipeline that gets applied automatically through something like Tecton pipelines that we have inside OpenShift or Argo CD. And you wouldn't come in here and necessarily do what we're going to do now. But one of the ways that you can get that in place is to come in, go back to our project, go down to our Solana API, to our installed operators, go to our 3Scale backend, create the backend, go to YAML view, and just paste that in. and hit create. Okay. So what that does is it declared to the system, hey, I want another backend that we can incorporate into our API. Let's take a look to make sure that that actually happened. We can come in and look at our backends, and we should see our Solana swap demo. And we do. So this was last updated, well, created today at this point in time. Okay. It's just the time of the server is a little off. Okay, now we need to do the same thing for our product definition, but the product definition we are just going to update rather than create. Let's go back to our project, Solana API, installed operators, 3Scale, and go to our 3Scale product that already exists, and we can modify the YAML here. Again, you would use something like Argo CD. Argo CD is a very powerful way of syncing these custom resources with the Openshift platform. And automatically, what the operator does is it looks at the definition, and if you apply changes to it, it will detect the changes and make that state reflect in the environment. All right, so the changes that we need to make are, we can kind of come down here and look, right? So what do we want? We have added, well, we've already added a core backend for swapping. Because we added a new backend with its own system name, we do need to add a new section here, given the Solana swap demo system name, and then we have a new path for that. And then we also have to come down here and add a new mapping. So a new mapping rule. So we would add a new mapping rule for every endpoint at that back end. So we have the core path, demo swaps, and then the path in the actual backend swap. And we will come down and take a look at anything else that we might need to add. We're going to add another method under methods. So since we already have that swap, we're going to copy this one. So copy. We're going to call this swap demo tokens. Even though we will be swapping the real thing, we're just adding a new endpoint. So swap 2 liquidity pool tokens for the demo. Swap demo tokens. And we want to add to our free plan a metric. Maybe we want to limit in the free plan. So there could be any number of plans in here. We want to limit the free plan of swap demo tokens to 50 per hour. And that should be it. We can go ahead and hit save. Okay, that is going and modifying our product now, so that our product will have the new endpoint defined. So integration, so mapping rules, we should see our pretty soon appear swap demo token in here. All right, you'll notice we have our demo swaps swap mapping rule that matches what we defined in the product definition, and that will lead us to the back end. So we have our product, which is mapped now to our Solana swap demo backend. So if we were to come in here and take a look at our backends, for example, at a high level, we can see that our Solana swap demo is linked to one product, and that product is our Solana API. You'll notice we have a warning symbol here that we need to push our changes on up to production. Okay, we're going to promote that to production. Now we're ready to take a look at our OpenAPI specification. We're almost to the point of opening this up for our end developers, but we need for that live documentation to reflect the new endpoint that we're creating. Right now, it only has that original swap function, but we want our swap demo function our swap demo endpoint that we're creating. To do that, we're going to edit this. And because we have pretty much the same endpoint already in place, we're going to copy this. Copy that. I believe that's okay. So we're going to take this guy. And in the section that we just copied, we have to update this core path to demo swaps, and we can pretty much leave everything else the same. And go ahead and update the spec. Let's take a look at what developers will see now. So let's go into our audience. This is the admin section of 3Scale. But for developers, you'll notice, you can take a look at your list, approve them or disapprove them, apply various levels of plans that they can use that are metered and have usage limits. And then we can come and take a look at the developer portal. So let's go ahead and visit the portal. We can sign in. So I'm going to sign in as me. I'm going to take a look at my documentation. And as a developer now, I want to know how to use this API. And I can come in thanks to OpenAPI spec. So our OpenAPI specification, I can go ahead and try this out. So just like we did in our local environment, now we can do the same thing as a developer. We're at a real domain name. So 3scale.enterprisewebservice.com. We could come in here too. All right, let's make this real. So get started. Go to documentation. This is what a developer will see. Click this. Hey, I want to try this guy out. I want to see if I can actually swap some tokens. All right, let's do the same thing we did before. I'm going to fill in the information we need. All right, we're going to be swapping from USDC. This is the public address, to our Enterprise Web Service token. and the liquidity pool that is going to facilitate the permissionless transaction. We're going to do 0.02 this time, let's say. All right, we should get 80. Let's allow 0.5 for slippage. We also select, defined in our OpenAPI specification, I dynamically pull the user key that 3Scale has for each user when they log into the developer portal that secures the access to the API. So that's a setting that you can modify. If we go back to our products and take a look at our settings, I have chosen to secure the API with an API key, but we could also use an OpenID Connect provider. And on top of that, if we go and take a look at our audience again and our applications or our developer portal, you can also choose to have various SSO single sign-on integrations for developers to be able to log into the developer portal. Red Hat single sign-on, Red Hat single sign-on can be used as the OpenID Connect provider to secure the API. It can also be used to secure the developer portal and allow people to use those credentials to log in rather than a username and password. Okay, now let's get back here, and I'm going to again populate the request body with my private key and other information off camera. 1 second. Okay, I have populated the request body above and all of the request parameters. So let's check our balance of enterprise web service tokens. All right, after we hit execute, we should have around 584 tokens. Let's go ahead and do that. And let's watch our balance. We have a successful transaction, and we have 586 enterprise web service tokens. All right. Now we have a pretty good start on a production level API foundation. You'll want to include some things that can automatically monitor and send you alerts on each of these endpoints to make sure they're up. There is a lot of useful software inside OpenShift. Really, there is no limit to it because new operators are being included and developed every day. So you could come in here and do service registry. If you wanted a single source of truth for your OpenAPI specifications, you could include that. So install the operator and then allow that to retain your specifications and pull from there. You can also, maybe you want to do something like mock your endpoints. So let's say we wanted microx. So we have our microx operator that can be your open source mocking and testing platform for the API that you've created that will lead you to not needing an implementation right away. You can create your OpenAPI specification, deploy that, create your 3Scale endpoints, and give developers access to the documentation and allow them to live request something that wouldn't necessarily have to be fully implemented. There's that as well. So there's really quite a lot that you can do within the OpenShift ecosystem. And so this is definitely a good foundation for creating your API application, driven architecture and software projects. So I appreciate you taking the time to watch this. Hopefully the crypto content was of interest to you as well. And, you can see how from small pieces, you can create very powerful things. You just keep adding to it, and then do things right early and often, and you can create a very solid foundation from there. All right. Thank you. Bye.